Hello, everyone. Thank you for joining us today. My name is Julio Perez, and I'm a solutions engineer here at Arista Networks. Today, I'm joined by my colleague, Peter. Peter, thank you for joining us today. And would you like to give a little brief introduction of yourself?
Yeah, my name is Peter. Thanks for starting the introduction. And I'm working for Arista Advanced Services, and I'm very happy to explain something about the code spaces today.
Yeah, so something interesting, and this is actually code spaces for network engineers, or specifically GitHub code spaces. Could you give anyone watching that may not have any idea what a code space is, what is a GitHub code spaces? And I'll actually stop my share, and then you can take over and give us a little introduction here.
Yeah, that would be great. So let me actually share my screen, because that would be a bit more productive in that case.
Sure.
So apparently, code spaces is a GitHub feature. And this feature is super cool. However, I think it's essential before we start talking about code spaces themselves, understand what is the background of the code space. After all, the code space itself is a container running in the GitHub cloud. And on top of this container, you can deploy a lot of stuff like on top of any other container, basically. This is a bit special kind of a container though. So if you take a look at this web page, for example, and it's highlighted here. So there is a specification for dev containers or development containers, which was originally started by Microsoft, but it's actively used by entire development community. It's very well known there. And we as network engineers are just starting to pick it up as well. So the idea of dev container is that you can spin like entire development environment in seconds, and you need like very low effort to build the dev container compared to like, let's say, a normal container from the Docker file. Yeah. So you can take a look at the specification here, but basically here is a small snapshot. So it's just a JSON file that you craft, and there is a number of supporting tools that can open this file. The first of them is VS Code. That means if you have ever used VS Code, and that's actually an amazing tool, even for network engineer. So once you have the dev container JSON definition in your repository, you can instantly open the entire environment that can contain anything inside. Yeah. And you can take a look at this documentation, which is specifically related to VS Code. However, this is not our main focus for today. So we will be focusing on code spaces, and it's exactly the same thing, which will not be running on your local machine, but on GitHub Cloud. You can
Sure.
still run it on your local machine as well.
Let me take a quick step back. So the thought process there being that, developing in a container in times past, we would have to, we'd either have like a requirements.txt file, maybe a Python virtual environment. If it's a Python project, we'd install our requirements. We'd essentially have to install all these packages to get started, even to start developing in a project or maybe working with a specific tool. I think the thought process being that in dev containers or just containers in general, you could essentially package these environments, and someone can essentially use the exact same environment that Peter was using when he was developing or he was creating some type of project.
Yeah. And it's maybe I will tell a few words. So because for us, so the entire idea was coming from the Arista validated design development. So, and as part of developing this Ansible collection, so we had a need to create a consistent way of building environments, so where you have all the dependencies and so on. And what we have done, so we essentially, if you can click here, you will see that we, on every release, and even for any development branch, we basically start building packages. Yeah. So, and so we have number of packages for different use cases, and those are the pre-built containers that you can use to power your development environment. you can then even start your lab directly in there, so which I will show to you. But that's essentially from where it came originally. So like the need to craft environment for every customer project is from where demand comes from us.
Okay, so now how does this all tie into CodeSpace? So we have dev containers, we started with AVD, we developed a dev container environment, but then how did we start on CodeSpaces? Like how did you go down the journey of working with CodeSpaces, or maybe even the why a CodeSpace? Why would I use a CodeSpace?
Yeah, and that's actually easy to explain. So I think we just start directly with a demo. So imagine, so this is a pretty standard website deployed with make docs on GitHub pages. And that's actually the amazing part of it. Like everything you see here is powered by GitHub end to end. So, I mean, this is actually amazing what GitHub is capable to do for open source right now. So, and the very first thing we are going to do is it's still a bit under construction, so it's like I would call it initial release. So, but we only have 2 demos here right now and 1 container lab workshop. So that's pretty much what we have. So we pick the classic ones, so with EVPN and MLAG. And so if you are using CodeSpace, this is literally how simple it is for you to start the entire lab environment. So you click this button. So once you click the button, you are redirected to a GitHub code space. And if you haven't set any tokens, by the way, it would suggest you, okay, you have to define the token to download Arista images. I mean, if you're Arista customers, you can easily generate this token under your profile, but you can also upload the image manually once the code space started. And well, this is actually a reasonably sized demo. You can see the topology here. So it's 2 spines, 4 leaves, and 2 hosts. So in total, as you can see, it's 8 machines. It can generally fit, nevertheless, into 4 core code space machine. I generally prefer to get a bigger one. So amazing that GitHub gives you all that for free. And I will talk about the billing in a few seconds. But you get actually 4 core CPUs by default if you want actually a bigger sizing. And you can see it can go really huge, right? So you only have to write GitHub support, and they enable that for you. That's how easy actually that works right now. And I pick actually 16 cores because in that case, our whole experience will be much smoother and actually much faster. And I click create code space. Yeah, so with that, I'm basically spinning the entire environment. So, and while it's actually up and running, so we can be talking about the rest of the stuff. It's actually not long, so I mean it's pretty much around the minutes. So as you can see, now the code space has started. You can also see that the dev container definition is really powerful specification. So because as part of this specification, we have a post create script which, for example, downloading the image for us and actually doing the rest of the stuff, that would be quite hard to do otherwise. But the thing is, you can also upload anything. Like if you don't have access to the token, you can just upload the image manually to the code space and do all this quite or kind of stuff actually smoothly. So with that, I
So
will quickly hand over. Yeah.
sure. So essentially, this is grabbing a specific version of CEOS or containerized EOS from Arista.com, importing it into this lab environment. Your PostScript command, I'm assuming, is doing some type of import into Docker, which will then actually start the lab. The lab you showed us with like 2 spines, 4 leaves, and like 2 Linux nodes, or 2 hosts, I should say.
Yeah, the post create script is doing, let's say, some, it's not really magic. So there is a tool, a Python library called EOS Downloader, which is doing most of the work. But the post create script is doing a bit more because it's initializing this entire thing as a Git repository for me. And it can do anything else I need to prepare my demo environment before we start. Like, for example, add aliases for every single switch I have in the lab. So this is also done under the hood automatically, that I can type just the switch host name and get access to this switch instantly.
Yeah, something really powerful here is you showed us this demo a few weeks back, and I was pretty blown away by everything you've created, or all of these tools that you've tied together to create this code space environment. Because in the past, or folks may know watching this now, is that you'd either have something like a GNS3 and EVE-NG, or maybe something like a container lab to get a lab environment going. But even with those amazing tools, like there's still a process to either maybe you require physical hardware to have a VM, or install directly on physical or bare metal, and then you have to install your packages, you have to download your images, you have to either send those images to your VM, or whatever it may be.
Mhm.
Then you have to create your topology, connect the links, right? There's a lot of processes to get going, even if you just want to start some type of environment to get started, either whether you're learning or testing out a network vendor's image or OS, or even trying to learn automation with specific tool sets. So when you showed us this demo a few weeks back, it was pretty amazing to see how seamless it really was to get this going.
Yeah. And with this approach, you can see that pretty much everything is pre-installed. If I do like Ansible dash version, for example, you will see that the Ansible pre-installed. I can do Ansible Galaxy, if I can type today, collection. Uh, I'm bad in typing. I'm always creating shortcuts for everything and so on. But that is pre-installed, and the best part of it is that we also have Container Lab dash. I think that was dash version. Not sure. Probably
I believe it's just
maybe
version. Yeah,
that.
yeah.
Yeah.
There
So
we go.
Container
There
Lab
we go.
version. Yeah. So and you can see it's also pre-installed. Yeah. So, well, the king of that, of course, is the GitHub infrastructure, but our COS lab image is adding a lot, because it's quite a marvel of engineering, I have to say. Like every single switch when you start it as a container, they occupies just 1 gig of memory. So, and I can even in the smallest host space, I can actually pack quite a few. And Container Lab is just making that a bit easier, so to start actually all these things. So because it's already a useful project, we don't have to redo all this work, right? So one more thing that I want to mention regarding how we power these labs on these actually repositories that we are focusing on currently, yeah, in code spaces. So as I said, like the entire idea came initially from the development process of AVD repo, and as I said, we are pre-building the containers as part of every AVD release. So the container definitions are here, and there is one important thing, actually only one thing that I want to show to you. Like if I go to, for example, this container definition, and there is, dev container JSON in here. As you can see, like normally the definition of every dev container includes, some Docker file, or maybe you refer to a pre-built container image. And you might have some customization, which is pre-installed VS Code extensions. But the features are the most important, part of dev container specification, because in just a few lines, you can do add a lot of code into your container to install certain things. And the entire demo that we were just looking at is relying on Docker in Docker. So basically, what happens when you start a code space? The code space already has Docker installed inside container. And with that, when you execute a shortcut to start your container lab, the container lab starts spinning more containers with COS lab inside the code space. So this is really like deep level of encapsulation, but this is totally possible thanks to modern technologies, and works perfectly on code space and normally on any other machine where you have Docker, right? So and to build that inside our container, it takes us just these 3 lines. So it's not a lot of work that we have done to enable it.
So you can see features are a very powerful feature in themselves, right? Specifying those 3 lines, you get an entire new software instance or configurations installed on your dev container.
So with a shortcut, so because as I said, I don't like typing, I can start the entire lab like that. So I can actually start it directly when the code spaces are, is deployed. So, but I prefer to have it as a separate step. After all, this lab is made for engineers. And so I just want to make it actually visible what is happening. I think that's actually crucial. So, by the way, before I actually go further, so if you want to see, to access these demos, so basically you can scour this QR code and there will be like link to the repository in the video. So, and you can play with that yourself. So it's quite straightforward. So while it's
Yeah,
building, yeah.
just one more call out. Go ahead and either scan the QR code. We'll also include links to literally anything we talk about today in the description.
Yeah. And while it's building, I would like to go through maybe some pieces of how it's working. So because after all, you see, it looks like a simple make docs website and a button, right? So I would say it's really not hard to craft this thing if you know how things are working. But after all, there is an enormous list of open source projects engaged in the whole experience here. And as you can see, like, okay, we have make docs, we have code spaces. Yeah, so if you click here, for example, you will see instantly, slides opened for every single workshops and demo that will be actually part of this repository. But I go to the repository right now, and I will show you a few ideas of how that works. So one fundamental part of what we have to power this process is pre-built containers. So because as you can see, you have packages here. Yeah. So and for every single demo, we essentially pre-built a dedicated container with entire environment except COS that we have to download separately. That means this environment never changes. It's always consistent, so you can access it at all times. And that is powered by a workflow specified here. And you can see that for every single demo, I have a workflow, and I also have the workflow to publish, the make docs on GitHub pages. So the next thing is we have containers definition, and actually we use these container definitions to pre-build the containers that power the demo. So apart from that, we have slides, and slides I have just shown that are powered by an open source project which is called MARP. Yeah, so and I find this quite neat, yeah. So because you can create slides in minutes in Markdown, so which is a super powerful way. So going back actually to here, so to build that, I mean, if you start thinking actually, so you have to create a make docs document. You have to create a workflow to create pre-built container. You have to create a pre-built container definition. You have to put all that actually together and hope that works. I mean, imagine how much time you would spend just on that. So the best case, it's templated by a Python library called Cookie Cutter. And for a standard, like lab, it takes just 1 second to call actually a shortcut and get, all that created for you, and then you can merge that and have this as a part of your repo. So and start actually building the rest of the content. So it's a lot of things spinning under the hood, a lot of actually backend stuff to provide this seamless experience, but it's all open source, it's all GitHub, and that's actually the beauty of it.
Yeah, I thought it was pretty amazing how you've really coupled together so many open source tools to essentially show off how you can build a platform where network engineers can be engaged in within code spaces, right? Whether it's Mart for slides, obviously GitHub code spaces, you have Container Lab. It's really been fascinating to watch.
Yeah. So as you can see, the Container Lab has started. And one more thing, actually, I want to show you. So we will not be focusing on that. So, I mean, we have a lot of amazing Arista tool. But as you can see, actually, all these devices in the lab essentially started streaming to our Cloud Vision as a Service instance, which is a cloud-based solution to provide, seamless automation experience for our customers. So I'm going to skip this part. I just want to show that your code space can interact with anything else actually you had out there available in internet and so on. And that's actually quite cool by itself as well. So I'll switch to the VS Code interface because that's actually in focus today, and that will be a bit faster for us. And I will open a new terminal. I can easily open a new terminal directly in VS Code. And as I said, my post create script have created aliases for me. If I just type actually the host name, as you can see, I'm on a switch right now. Yeah. And if I do show BGP EVPN summary, I shouldn't get anything because, well, it's not even valid. Even if I do show
Sure.
IP BGP summary, there is nothing. So because we haven't enabled anything yet, right? So
Right. We're at a bare
what
bones
we're going to do,
configuration.
yes. So what we're
Mhm.
going to do, we're going to execute an Ansible playbook, which will run Ansible AVD for us. And this playbook will build entire EVPN configuration. And as you can see, that all happens effortlessly by default in a pre-provisioned environment. So it would actually took you quite some time to prepare that otherwise.
So again,
But
back to like the
yeah,
benefit of code spaces, the benefit of containers, since this environment was already prepped, everything's pre-installed. You don't have to install the AVD collection or the required Python packages. It's already ready. So you essentially could just run your make build from the jump.
yes, yeah. So so once we have the configuration generated by AVD, so we can actually take a look into this configuration. So for that, we can go to AVD inventory, and here actually in intended, we can see that there will be some configs actually generated for us, and I can click on this one. You can see actually this is the configuration that was generated by AVD. So now we want actually to send this configuration to the switch. So we want to switch being actually configured, right? So, and for that, we run another playbook. We can merge these two, depends on our preference, but deploy underscore eAPI is a shortcut that allows me to send my config to all my devices across entire network. And if I go to the switch now and I do show IP BGP summary, so yeah, so probably I wasn't fast enough. So you see the BGP sessions already came up, and show BGP EVPN summary will show me that also EVPN session established. I mean, I can actually send a ping from the host or something, so but I think it's not in
Sure.
the focus of our demo. So one more thing I want to show here is that with the help of AVD and a collection that is called ANTA, which is Arista Network Test Automation, we can validate the entire deployment in seconds. Yeah. So if I do actually make tests, so this will collect the information about my network and compare that with the intended state with what we actually expect. And if I'm running that in a CI pipeline or something, this will raise an error, and the CI can break and tell, okay, something is wrong. But even if you don't use any CI, so that can be useful because there is a markdown report here, which you can open and take a look. Yeah. So, well, apparently, as you can see, and I can repeat that in a couple of seconds. Yeah. So this is actually a good example of validation running. I have some failed tests, which is NTP, because NTP takes a bit of time to fix. And so if we will double check that in a few seconds, you will see that actually is fixed. Maybe let's try to repeat that and see if it actually already fixed or not.
So while this is running, it's pretty amazing. So you've, again, going back to open source projects, you've tied AVD to run the build, run the deployment, and also used Anta to run, or Anta with AVD to run the validation steps of your deployed topology. Something that's also interesting to me when you showed us this demo was that, yes, in this environment, in these labs, we're trying to show people, one, what is possible, but also what is possible with Arista, what's possible with our technology, even if you're doing something like an L3LS deployment. But there's also something to be said that with these code spaces, them being, right size and depending on your topology, yes, in this environment, it's sort of showing a complete build. But I found this interesting as a learning opportunity, or for network engineers that are just trying to learn, either getting started in their career or wanting to dive into a specific vendor's technology. They could essentially run one of these labs and sort of either go through a course or go through a book and essentially be learning as they go using these open source tools, using GitHub code spaces. It's a pretty powerful combination, I think.
Yeah, absolutely. So, and I mean, there are a lot of things, a lot of situations where you can apply that. After all, if you actually think about it, so this is completely portable. So on every single lab I'm showing here on Codespaces, you can also run directly on your machine. If you have at least, x86 machine, you click on this file, right? So you get the demo instantly downloaded, and you can open that in VS Code using exactly the same container, and you will have actually exactly the same experience. But with Codespaces, that can provide you like really one-click way of power the stuff. You can merge that with whatever actually things you can imagine. So it's convenient when you are playing in some kind of workshop. It's convenient when you are, for example, traveling. So because it just spinning somewhere remotely, so not wasting your CPU cycles. One way how we use actually Codespaces, if I open quickly an AVD collection documentation again, so if I click on our repo, and you can see there is number of PRs in here. So I can pick, well, I pick just some random actually PRs that we have there. And if I click here, I can just, spin the code space directly on GitHub, and I can start, validating certain stuff directly in this code space, which is super helpful for PR reviews. But I think this is a bit advanced case for network engineers. However, I mean, I just want to show that the possibilities are really endless. And one important thing is, well, before I go to that, I just want to show that, okay, I run actually the test again. And as you can see now, it's all fixed. So I have all the tests passed, including actually NTP. So it's completely sane environment. But I wanted to tell that there is a huge interest, at least from development community for the similar functionality. And there was an entire startup, which is called Project Daytona. Yeah, so it was started relatively recently, like a few months ago. In the first, I think 1 or 2 weeks, it collected like 4,000 stars on GitHub. And the idea of this project was, okay, what if we give our customers code space, but essentially in any environment, like be it your enterprise server or actually AWS or anything. Yeah. So, and the project was open sourced. They are going to charge on some security features and so on. So like 4,000 stars in 2 weeks, that shows like how much people do need that outside of GitHub infrastructure. However, with a bit of creativity, you can even build it by yourself. So because, I mean, Microsoft is so gracious, like if you think the entire Codespaces experience is powered by a tool which is called Dev Container CLI. Like that is what the Microsoft is using under the hood to start them. And it's open source. I mean, you have entire CLI here. So like you can use it on your machine, on any machine, be it your Linux server, be it your laptop, anything, to spawn dev containers. And if you are technically savvy enough to write an API that would then actually trigger the dev container CLI, you have everything you need to replicate same kind of experience in any environment. Yeah. So that's how powerful that is. Furthermore, a few words on the cost of the entire thing. So Microsoft GitHub gives you essentially 120 core hours for free to play with code spaces. Yeah. So, and let me actually scroll to the relevant section. When I need it, I cannot actually find it. So which is code spaces? Yeah, here is code spaces, right? So essentially you can see this 120 core hours. That means if you have, let's say, a 4-core machines, approximately in a month, you will get around 30 hours to play with code spaces for free. And that's not a small amount. I mean, even though I'm using code spaces intensively, um, I'm normally not even charged actually by Microsoft. So the probability to hit, this limit appears when you are running, the machines with higher number of cores, for actually a longer time. But even then, if you calculate the prices, and prices are provided like directly here, and if you think, okay, 4-core machine can power, well, at least 4 containers, yeah? So that means actually 4 nodes. And if you actually, calculate price per node per hour, that is really low, right? So that is actually below 10 cents per hour for a single node. Actually, in reality, it's even less, because even on this code space, you can run a bit more. Yeah, you don't have to pay. I have spent like a 50, US dollars monthly limit. I never crossed that. Most of the cases, I'm even actually in this free time. Yeah.
Yeah, when I started down, or excuse me, when you gave us the demo, I also just assumed that CodeSpaces was just free, whereas I didn't know there was actually like a limit, or they would essentially, it's important to know that even though it is open source, there is a cost, right? There's some compute somewhere running all of this
Yeah.
in GitHub's infrastructure.
For code spaces specifically, yes. So you get certain amount for free, and then if you're out of that, you will be charged. But for majority of users, for example, doing something like, this workshop, this one, like if you go here, if you click this button, and you start playing just with a single workshop in a month, which is like most likely the case, you will not run out of this free time, because normally the amount of time that is provided is actually sufficient. Yeah. Um, so therefore, for majority of users, probably the paid plan will not be required anyway. And Microsoft has some discounts for universities, for students, if actually that matters for someone who is listening for us.
No, Peter, I think this was amazing. Yeah, just thank you for showing us what you've built, showing us all the open source tools you've coupled together, to create an experience like this. I just want to say thank you personally for joining me on this conversation. It's been super insightful, and I hope it helps someone down the road. Or please, click on one of these links and feel free to explore what Peter's built, and feel free to run through one of the labs.
Yep. Thank you, and thank you for you, Julio.
Cheers. All right. Thank you, everybody.
Thank you.